Hi everyone, so today we're going to be discussing the released question from the 2019 AP Calculus AB free response, question 6. So there are only 6 questions on the exam, so this was the last question. And we're going to be discussing how to solve this problem and then how to get your points. So this is what it looks like. Part A is asking to find h prime of 2. So first I'm going to start by writing down all the information we know so far. So we know that g of 2 equals h of 2 equals 4. And then we also know that we have this equation y equals 4 plus 2/3 x minus 2. And this line is tangent to both of these graphs. So it's asking for h prime of 2. And because this equation is the equation for the tangent line, this is the slope right here. This is point slope form, and this is the slope right here. And when we remember that when we take the derivative, h prime of x is the slope of h of x. So this is the slope. So h prime of 2 equals 2/3. Okay, so on that one, there's only 1 point. And it's just going to be with the answer. Okay, so part B. It is asking you to write the expression for a prime of x and to find a prime of 2. And you're given a of x equals 3x to the third h of x. So you may remember that we can't differentiate a product without the product rule. So this is how I like to remember the product rule. AB prime plus BA prime. So I also like to note which is which. So here I'm using a as 3x to the third, and a prime is the derivative of this, so that would be 9x squared. B here would be h of x, and it's really easy. B prime here is just h prime of x. So I just like to separate my work and make notes so that I know which steps I'm taking, and it's easier for me to find a mistake. So first we're gonna plug all these values into the product rule right here. So a prime of x equals 3x to the third times h prime of x. So once again, that is a b prime plus, I'm going to do 9x squared times h of x, which is that ba prime term. So that is your derivative. That is actually your expression for a prime of x right here. So next it's asking you find a prime of 2. So that's pretty easy. We're just going to plug in all the values. So here, 2 to the third is 8 times 3 is 24. So up here we found h prime of 2, and we're going to use that here. So h prime of 2 is 2/3, so we're going to plug that in. Plus, so here we have 2 squared is 4 times 9 is 36 times h prime of 2. Up here we have h of 2, I'm sorry, I misspoke, is 4. So 36 times 4. And you can either leave it like this or you can simplify it. You end up getting 160. This is equivalent. It's completely equivalent to 160. Here you're getting 3 points for part B. So you're getting a point for the form of the product rule for demonstrating that you know what the product rule is, essentially. So that you can get that point for a of x, for showing you use the product rule. And then for getting the expression a prime of x, you get the same point. So you can get 2 points for a prime of x if it is written out correctly. So your third point here is going to be finding a prime of 2. Here, the answer is either 160 or this value here, because the two are equivalent. Alright, so next we're going to move on to part C. You have to know the information that the problem has already given you, and you have to be able to apply it in this problem, and that's a little difficult when you feel like you're being rushed by the time limit. So I suggest writing down, just noting everything the problem tells you so that you have it for later. H of x equals x squared minus 4 over 1 minus f of x quantity cubed for everything at all values x that do not equal 2. So it is also known that the limit of h of x as x approaches 2 can be evaluated using L'Hopital's rule. So we're going to use the limit of h of x as x approaches 2 to find f of 2 and f prime of 2. So we need f of 2 and f prime of 2. And this is just so we remember it, so it doesn't get lost in all the rest of the work we're about to do. Alright, so we also know, because f, g, and h, it says in the top portion of the problem, that they are twice differentiable functions, and a function is only differentiable if it's continuous, so differentiability implies continuity. So here we're going to evaluate the limit of h of x as x approaches 2. So the limit as x approaches 2 of h of x equals the limit as x approaches 2 x squared minus 4 over 1 minus f of x cubed. So here we know that the limit of h of x as x approaches 2 equals 4 because of this right here. So we're going to set this equal to 4. And we're going to remember this because we're going to need it eventually again. So when you plug this in, x squared, so 2 squared minus 4 is 0, and then this value here, once again, is 0. So that's an indeterminate form, and we're going to evaluate the two limits separately, because if we show that we're evaluating the limits together, you might not get the points that you may deserve for this problem. So here we're going to evaluate the limit as x approaches 2, x squared minus 4 equals 0. Here, the limit as x approaches 2 of 1 minus f of x cubed. So because this equals 0, because this right here equals 0, this must also equal 0. Because we know that L'Hopital's rule can be used to evaluate the limit of h of x as x approaches 2. So for this to be indeterminate form, this has to equal 0. So because this equals 0, then the limit of as x approaches 2 of f of x equals 1. So the limit of f of x as x approaches 2 has to equal 1 here, because 1, if this were 1, 1 cubed is 1. 1 minus 1 equals 0. So because we know that, f of 2 equals 1. So f of 2 equals 1. Okay. So now we're going to use L'Hopital's rule, and we're going to take the derivative of the top and the bottom of the limit. So the limit as x approaches 2, so to take the derivative right here, x squared, this 4 is gonna cancel out. The x squared now becomes a 2x So to plug in 2 to this x, we get a 4. And then the limit as x approaches 2. So to take the derivative here, it would be, this 1 will cancel out. This is still a negative. So it's going to be a negative 3 because we're going to use the chain rule here, and we're going to multiply this 3 to the outside. Now, it's going to be 3 times f of x squared times, we're going to chain on the derivative of the inside, times f prime of x equals, okay, so this is where it gets a little bit tricky. We're going to continue to evaluate this. Here it is, so because this is over top, this is going to be, so f of 2 equals 1. So this right here is going to be 1. So it equals negative 3 times 1 squared times f prime of x. Or f prime of 2 because we did plug in the 2 to this x. So now we're going to look at dividing these. So 4 over negative 3 times 1 squared, this is just negative 3, times f prime of 2. Because this limit up here equals 4, right here, this has to equal 4. Alright, and now we're going to just solve, we're gonna solve for f of 2, f prime of 2. So here we're gonna divide, we're actually going to multiply by negative 3 over 4 to cancel this out right here. And that is going to give us a negative 3. So 1 over f prime of 2, 1 over f prime of 2 equals negative 3. So if we multiply this f prime of 2 and divide this negative 3, so it cancels this out, negative 3 times 1. So f prime of 2 equals negative 3. I'm sorry, negative 1/3. We're dividing. I made a mistake right here. Instead of multiplying, we're dividing. So there you go. F prime of 2 equals negative 1/3. Okay, so that's the end of part C. And I'm going to show you where you're going to get your points. So you get a point here for knowing that the limit of h of x as x approaches 2 equals 4. You were asked to evaluate that limit using L'Hopital's rule. So now you get another point for figuring out what f of 2 is right here based on the information that you received previously. So you get another point for using L'Hopital's rule up here. And your last point in this is finding f prime of 2. I think this was the hardest part of the problem because you honestly, to all of the different layers of this section, you needed to apply information that you knew from previous sections and just mesh it all together, and then of course with the algebra skills you had to bring it together. So I think that was the most difficult part. G of x is less than or equal to k of x is less than or equal to h of x on the interval 1 to 3. So it's asking, is k continuous at x equals 2? And then we're asked to justify. So from earlier parts of the problem, we know that g and h are both continuous. So this is the information we already knew, and this is where I'm going to start my justification. So g of x and h of x are both continuous because as I said earlier, differentiability implies continuity. So we're also going to evaluate the limit. The limit as x approaches 2, g of x equals g of 2 equals 4, and that's the same for h of x. So that equals the limit as x approaches 2 of h of x equals h of 2 equals 4. So this usually sets you up for some sort of theorem, and the implication of continuity. So because of this condition right here, the squeeze theorem applies here. And the squeeze theorem can tell you if k is continuous at x equals 2. So according to the squeeze theorem, the limit of k of x as x approaches 2 also equals 4. And so 4 is less than or equal to 4 is less than or equal to 4. Of course, these are all equal, but this is g, k, and h. So k is continuous. And this can also be seen, so if you were to draw this out, alright, let's say, I guess we really don't know what g of x and h of x look like, but let's say this were g of x, let's say this were h of x, and this is at x equals 2. So this x equals 2, k could be whatever, as long as it is between the values of g of x and h of x. So that's all. I really recommend writing out notes as you go and just keeping the information with you throughout the problem, because a lot of it can help you, as we saw in part C. Good luck. So here you're going to get you only have 1 point for this question, so it's just that you state that k is continuous with the correct justification, so this is just 1 point.